Okay. Hello, everyone. Great to see you. My name is Chad Sanderson, and we are here with Mark Kidwell. And we're really excited today to talk to you about MLOps and data platforms. Mark, do you want to introduce yourself?
Sure. Thanks for having me today, Chad. My name is Mark Kidwell. I'm the Chief Data Architect, the Autodesk data platform. I work for Autodesk, and I've been with Autodesk about 3 years, working on this platform. Before that, I was consulting with Autodesk, and I've had a number of software engineering management and data management roles in my career.
Excellent. Great. Could you, I think something that would be really interesting to start, because the definitions are important, but how do you define MLOps, and what do you think the role of MLOps is when it comes to building and supporting data platforms?
Yeah, it's a good question, and we just went through an exercise trying to answer some of these things. Everybody's talking about MLOps, and it's could be seen as a buzzword without getting into what it is first. We view it the same way, or similarly to how we view data ops, which is something we almost take for granted now. But the ability for machine learning engineers, data scientists, everybody involved in the business of advanced analytics, using machine learning and AI to take their products and their activities and turn them into something repeatable, operationalized, something with an SLA, something that can run in production, not just a one-off notebook that's running on their desktop or laptop, but something that's reliably inferring every day or hourly or real time.
Got it. So would you say that the core of MLOps is really about scaling machine learning platforms beyond these like you said, a bespoke notebook running on a single data scientist machine to a consistent framework of operation for the whole company when it comes to like deploying, training, analyzing models?
Yeah, it's definitely about scaling up that process to enable a lot of these pipelines and workflows to run concurrently. And again, it's something we've been through with the data side and data pipelines, and don't realize that we started kind of the same way of analysts running things locally or having a need to automate these queries. It turns out now we have thousands of workflows running in production. We're not quite at the same scale within the Autodesk data platform for the ML side, but it's the same end goal to be able to support that.
Got it. Makes total sense. So I think this is a really relevant conversation for a bunch of different businesses right now that are just starting to dip their toe into the waters of machine learning, or maybe they've been doing it for the last couple of years and realize that some sort of centralized platform is really important to maintain consistency. When did you and the data platform team at Autodesk realize that this was an investment that you needed to make?
I think several teams realized it simultaneously. And I would say about 2 years ago, there was kind of this push towards maturing the ML operations and ML platform side of what our data science teams were doing. And a lot of them tried to do this on their own. A lot of them tried to build out mini platforms or bolt-on platforms on existing ones. It wasn't until fairly recently we stepped back and said, well, now we've kind of gone and built several platforms, but we almost have too many ways of doing things. How do we get this back to alignment with our data platform, our core principles for how we scale and operate things? and make it a general purpose offering. And I think that was only about a year, 6 months to a year ago that we took that on as an initiative, and began really making progress on that.
Mm. And would you say that the major benefits to the business outside of these, larger, more abstract benefits like, consistency and scalability and things like that, which I think are pretty hard to justify in the moment. It's more like we have a bunch of different teams that are all doing things. They're deploying models, they're training their data in very different ways. And there's a cost to that. There's a cost that each individual sort of organization has to bear. And the benefit of investing in a centralized system is that you can bear that cost on their behalf.
It's exactly the case. When people start, you usually don't start by building a platform because you don't have enough demand for it. You don't have enough of these ML pipelines or whatever it is that you want to run. It's only after you've started building those, and then each person or each team might build their own implementation of that you start realizing, okay, it's time to bring it back in and invest in a central platform to make it easier. And you're right about the business and economics of it aren't usually visible to the end users, the folks who are demanding, the improvements in inference and predictions and the other benefits that ML brings. They legitimately, had a use case and wanted it done quickly, and teams delivered. And so now it's about, okay, taking the things that have been built and maturing them, standardizing them, and improving the offering, making it more accessible to more teams, so they don't have to go through the same effort of building their own stack.
Makes sense. So you've been going down this road for sounds like a couple years now. Now that you've made some investments into MLOps, and to your point, still not quite as mature as the overall data platform, but certainly getting there. I think that's just the state of the industry right now. What are some of the things that you have learned that maybe you would have done differently if you had to go back in time and start over?
It's a great question. I think it might be easier in hindsight to name lots of things that we could do differently, but we didn't understand fully the workflows that users would adopt, our data science teams or ML engineering teams. We didn't understand all the resource needs. And I think one of the big things is we didn't understand all the data needs that teams have. Those are all technical problems. I mean, we had to kind of go forward, move back, go forward on some of these things. And in the case of some things like having the right data sets or having the right data platform and reliable data, it turned out to be a much larger effort, as always, to bring data into the platform to make sure it's high quality, ready to consume by different analytics products, including ML products. So would we have changed the approach or done something differently? I don't think we would have. I think we, continued to deliver value incrementally as we were building, different parts of our system. But just recognizing that all of these things take longer than you ever expect they will, and are a significant effort and investment. And so there's some patience required there. And at the same time, trying to build something that's our earliest testable product, deliver value quickly. Those are still our core principles to learn more about this as we're building it.
Great. Yeah, I think you said something that's really interesting and relevant, which is that you don't realize until you're building more of a centralized machine learning system that actually having very high quality centralized data pipelines is an equally important, if not significantly more important, or at least more difficult challenge. Could you talk a little bit about that? Like what having organized clean, usable data sets meant for the machine learning organization, and also maybe some of the steps that you took in order to get you closer to success down that path.
Yeah, I think we had embarked on our improvements on the data platform side to impact all of our analytics products and processes. And I think that was something that was overdue and needed, because we weren't able to meet the fundamental needs of our business and with our data platform of providing business ready data analytics. So that took a long time, probably longer than we originally anticipated, just reworking a lot of the pipelines, reworking a lot of our end-to-end ingestion, actually making everyone aware that we can't simply ingest data, we also have to test it. Publishing is a separate step from copying data in, and making everybody not just aware of it, but embrace that. Like, if you want these things to be high quality, we're going to add tests. It's going to add latency. It's going to result in better data, though, and so it's worth it. And it over time, I think people internalize that. When we talk to our internal users on the platform, our stakeholders, it's now part of our culture to talk about things like ingestion and publishing as separate acts with testing in between. How publishers of data products think about their data and how their consumers will use it. A lot of this stuff is also influenced by data mesh principles. And so we've brought all of that in, put it into the platform as part of the core tooling we offer, in addition to just the standards. And our aim with the ML platform is extend that, not just to certainly not to build a duplicate platform, but take everything that we've already done and be able to extend it and apply it to our ML platform, the same principles.
Yeah, I think that's really interesting. Testing is a bit of a bane, pretty much every organization that I've ever talked to. And it seems like what you're saying, to summarize a bit, is that by going through the act of centralization and providing pipelines, that you could be a bit prescriptive in how you get how you do ingestion, on what sort of requirements are necessary to get the data that you need for training or any analytics use case. And by being prescriptive, then you help create a strong culture of data quality and of ML quality as well. Is that sort of what you're saying? Is that, like, by creating the platform, you're also helping to create the culture? Or do you find that it's more the other way around, where you need the culture first, and you need to spend all your time getting people to understand, like, the value of testing, and then the platform can facilitate?
Yeah, it's like, which one of those came first? I think we started with the platform as just a collection of services, things that you went and queried or logged into or pushed a pipeline to. And the idea of the other parts that go into a data product, the strong testing and the publishing aspects, the metadata, and where we push everything into a catalog, those took time to develop afterwards. And even after we developed them, then it took more time to kind of build it into the culture for the consumers. So there's definitely a lag. I think in some ways the platform leads the culture, and in some ways it lags the culture, but we're trying to influence it both ways, where if there is a best practice, if there is something that we want people to embrace, we don't want them to have to think about those things or do them outside the platform. We want to build it into the platform.
Got it. Yeah, I think that's a really great way of looking at it, having sort of bi-directional influence. Your data consumers are influencing the platform, and the platform are influencing the data consumers. And so you have this sort of really nice flywheel on adopting best practices and potentially generating some new ones. So this has been awesome so far, and we have been operating at a bit of a high level as we talk about like what are the sort of motivations for building a platform, and how did you think about adoption. But it would be good to talk about a few specifics as well. So maybe you could just tell us a bit about the various components of the platform, and maybe it'd be good to start with the data platform since it's a superset. And then we could finish with the components of the machine learning platform.
Sure. Yeah, our data platform is comprised of an AWS data lake and a Snowflake data warehouse, and we're committed to maintaining both of those. We used to only be on the data lake and found that we couldn't meet enough of the requirements, I guess, that we had for the kinds of business analytics, BI, and more, you can call them traditional use cases for analytics without having a very strong data warehouse. And at the time, we were only using our data lake, largely using it as a data warehouse. So it made sense to move to the best data warehouse we could get our hands on, which, after looking at different options, we believe Snowflake was and still is that. But we still use the data lake heavily. We have data sets that are just too large to bring into the data warehouse, data sets that, because of their access patterns, aren't the right fit, or the kinds of processing we do on them. And those tend to be our event-based data sets around product usage. They measure in the billions of records every day compared to most of our business systems, which are probably 5 to 10% of that size daily. And in terms of the other components of the system on our data lake, we use Spark for all of our transformations. We orchestrate everything with Airflow. We have a lot of customized testing built into our workflows today, and are still working on how to standardize that. On this data warehouse side, again, the same scheduler, but we use dbt for most of our transformations, and a combination of no code and low code tools for ingestion, either Fivetran or Matillion. And we can also leverage more standardized testing with dbt on Snowflake. So, we've tried to keep the stack similar, though. We prefer people work in SQL no matter where they are. If there's not a compelling reason to go down and start writing custom code, then why bother? And that's been part of our standardizing the platform, to just make the tools standard, make their adoption standard, make their use very prescriptive and opinionated. In addition to these things, I mentioned metadata. We do have a metadata capture system, and a data catalog. Of course, we need to be able to search for objects and help discoverability. We use Amundsen for that. And it's become our kind of the nexus for surfacing metadata about data health, data quality. It links back to more information about data products that people have built. So that's the major components of our data platform.
Got it. That's all excellent. It sounds like you have totally adopted the modern data stack,
Yes.
which is great. So could you talk a little bit about how you're extending that stack into machine learning?
Sure. We are continuing to use the AWS platform. We're heavily invested in that, and especially all the SageMaker offerings. We have a large number of data scientists and teams that are very familiar with that. And so it's one of the core components of our ML platform. And the way we're extending the data platform into the ML platform is ensuring that there's complete compatibility, interoperability between the data platform as a source for all the data feeding the ML platform, and that things like feature engineering or data preparation work can be done leveraging the data in the data platform without any friction. No need to bring data out of our platform and put it in a different platform when it supports all that work right there. So there's tight integration from that point of view, but there's also support for external sources. At Autodesk, we do have a number of teams that want to bring their own data. We support that with our data platform too, joining data from outside the platform to data inside. And we want to allow teams to do the same thing, bring in their data to run on our ML platform, possibly join to data in the data platform, and not have any barriers to that. As far as the other aspects of it, SageMaker comes with a lot of features and capabilities out of the box. Most of our work is again around integration and automating those things, making sure they work in our environment, and leveraging some of the other tools we're already using. Again, Airflow for scheduling, ML pipelines.
Got it. Makes total sense. Now, one question I have for you is, what is the level of access that the data infrastructure team has? How does the access the data infrastructure team has to some of the various tools you mentioned, Airflow, DBT, and the rest of the data team, like your data scientists and analysts, people who work in SQL or Python? You mentioned a little while ago that you're adopting principles of data mesh. And for anybody who's not familiar, one of the core components of data mesh is like federated governance and ownership. So that I've always thought that was a really interesting question. Like, where does the ownership of these tools fall, and the usage of the tools fall as well? And do you have data scientists who are using DBT and they're sort of integrating with Fivetran and leveraging the connectors and everything else, or is that more of the responsibility of the team that's maintaining the platform, and then the various data teams are then leveraging the data products that your team generates?
Yeah, from a strict platform level perspective, like the tools like Fivetran and DBT are supported by the platform team, but not actually used by the platform team to bring in any data, except for some of our metadata that we use for cost or for monitoring and other observability efforts. All of these platform tools are available to any data team, every data team at Autodesk to come to our platform and start using them. And that said, we have some core data products that are owned by other teams in addition to the platform team. We're all part of one umbrella, even though there might be a platform team and different teams that are focused on some of our enterprise data or product data that are responsible for that first mile of getting these key data sets in and getting them ready for other teams to build their data products. But the goal is, again, that any data team can come in and do the same thing with these platform level capabilities. That there's nothing that's limited or off limits to these teams. To support that, the platform is meant to be multi-tenant and has security and guardrails around every tenant to prevent them from either clobbering someone else's data or seeing data that they're not entitled to. And then same thing for consuming data teams. They have the same limits around what they can see and do, and in turn what they can republish. But it is meant to be what is now articulated very well with the data mesh concept, that it can be completely decentralized and yet still governed in a way that any data consumer can find a data publisher's products, and vice versa. Publishers can communicate to their consumers or understand how their data are being used.
And before we go further, can you explain a little bit what you mean by data products? I'm familiar, but it's another one of those words that could mean something very different depending on how familiar you are with data and with frameworks like data mesh.
Yeah, I think in a nutshell, a data product physically is a collection of tables or views or whatever it is that a team has built with their ingestion and dbt pipelines. They publish something. They're publishing these data sets so that other users can come in and run Power BI against it, or build Looker dashboards against it. The idea, though, is not in this federated or multi-team, multi-tenant view is that there's no one core data team, but each team is responsible for their data sets. And treating it like a product means putting SLAs around it, guaranteeing the stability of the interface, telling your consumers, when you're about to make a change, or making sure you're getting their requirements and input. And then the role of the platform team is supporting all of those activities, supporting a common way to discover data, to find out its quality, to contact the owners, all of these activities.
Got it. And so we've sort of come full circle now, but really what you're describing through this, it makes complete sense why you see MLOps as an extension of the data platform. The data platform is rooted in these principles of federation, of open access, of leveraging tools and a relatively clear workflow to deliver these high quality data sets that you've described. And I would assume that the machine learning platform simply applies those exact same principles to leveraging the data with ML.
That's right. It's taking all the same principles and applying it to the ML tools, the ML workflows, but the same idea is that any data scientists or data team that has ML engineers or whatever their capabilities are can come in and have full access to the data, run feature engineering, prep, do model training and deployment and operations, the whole life cycle, and that they get the same benefits that any other team would have the same capabilities, and end users of these data products have the visibility into what's going on and are able to see this so that they can trust it. They can trust that the results are correct, that we're monitoring it, that the products are working as intended.
Excellent. Well, this has been an amazing overview and insight into the things that you are working on at Autodesk. And from my experience, being able to have very high quality data sets and machine learning workflows that anybody can access and leverage super simply is one of the biggest pain points in any organization that's starting to use machine learning. So it's really cool to see how far you guys are down that journey. Mark, where can people go to follow you or find out more information about you and what you're working on?
I've never been asked that question before, so I believe LinkedIn would be the best place to find me for my meager social media presence. But I will point out that Autodesk is, of course, hiring in all of these areas across our data platform and an ML platform. And you can also go to the Autodesk careers site to see what's open.
Excellent. Well, Mark, thank you for sitting down and having this conversation with me. And thank you to all of our listeners for tuning in. I hope you enjoy the rest of the summit.